Swadika. Hello everyone. This is Mindra Runsuk and I'm very pleased to present our Kai22 paper, Sad or Just Genius, using experience sampling to understand and detect negative affective experiences on Instagram. This work was conducted at UNIS Interactions Lab with my advisor Ian Oakley, in a collaboration with Kai's DXD Lab with my co-advisor Hwa Jong Hong and my colleague Taewon Kim. Social networking services or SNS are everywhere. 3.6 billion people are reported to have at least one SNS account, and the mean daily use time for SNS is over 2 hours. SNS users engage in a wide range of activities such as posting self-produced content or viewing, browsing, and reacting to content posted by their connections. This prevalent and prolonged media consumption impacts SNS users' emotional states. While this is mainly a positive outcome, with many users reporting feelings of relaxing or calm, it is also widely acknowledged that SNS activity can result in negative emotional states. This occurs when, for example, users view content and experience negative social comparison, body comparison, or other forms of envy. While individual experiences of this sort may be unconcerning, the high usage rates of SNS means that they can accumulate over time into more serious problems, such as what is commonly termed Facebook depression. We believe that cataloging these negative experiences is important and contribute to studies that do this. Both use experience sampling methods or ESM to repeatedly survey users about their affective states over prolonged periods and during the course of their regular day-to-day basis. In our first study, we seek to complement prior accounts of the emotions experienced during SNS use by capturing a wide range of relevant affective constructs directly after SNS browsing session. We report on the prevalence of different affective experiences, noting that appearance comparisons and envy show relative high incidence rate. In our second study, we focus on these two constructs. We use similar ESMs, but also capture smartphone sensor data in addition to self-report effects. We then use the self-reports data as labels to train classifiers based on the log sensor data, showing the potential to develop affect-aware system capable of detecting negative emotional experiences as they occur during daily SNS use. In our first study, we developed IG Use, an Android app that monitors phone app use and capture ESM survey data directly after an SNS use session, specifically an Instagram session. We recruit 19 participants, all regular users of Instagram, and capture self-reports over a 2-week period, ultimately collecting 837 surveys. The ESM survey was intentionally broad in scope and include assessments of violence, arousal, social comparisons, appearance comparisons, envy, self-esteem, and depression. To draw conclusions, we first discretize ratings for each construct into binary states and examine the frequency of each. The results indicate that the majority of Instagram use sessions led to positive affective experience and a minority result in negative affect. However, negative effects occur more frequently in passive use scenarios, such as viewing contents, than in active use scenarios, such as messaging or posting content. In addition, the negative affective states that were most prevalent at 16% and 17% were appearance comparisons, a construct linked to body dissatisfaction and envy. In sum, this study extends prior literature on affect and SNS by recording how frequently different negative affective experiences occur, highlighting constructs that are more prevalent and therefore strong candidates for further study. Building on these findings, we conducted a second ESM study focusing on passive SNS use and capturing only self-reports of appearance comparison and envy. Beyond logging affective states, this study sought also to capture the data that could enable them to be detected or predicted. To do this, the study used an extended version of IGU's app that presented Instagram as a web view that logged all motions and touch data during passive SNS use sessions, and that recorded survey immediately after sessions were completed. We then recruited 20 users and ran the study for 2 weeks. We recorded a total of 837 self-reports and associated sensor data logs. As in the first study, we discretized the self-reports into binary states. We again recorded predominantly positive affective states. Negative effects occur in 10% of sessions for appearance comparisons and 16% of sessions for envy. We developed classifiers to predict the self-report's effective states from the recorded sensor data. To do this, we split each Instagram use session into non-overlap 15 seconds windows and construct feature vectors composed of summary statistics such as mean, min, or max for each sensor channel. We then use the binary self-report data as label to train classifiers. We explore a wide range of model parameters, including variations in the classification algorithms, sensor data, normalization procedures, and the data binding techniques for the labels. To prevent overfitting, we use only default classifier parameters and conduct all analyses with leave one out cross-validation. The results indicate that performance can be achieved with RBF kernel SVM, with motion data alone, and adaptive data normalization procedures based on gradually changing baseline, and with simple data binding techniques based on scale midpoints. Peak accuracies for these configurations were high, 95.78% for binary appearance comparisons and 93.95% for binary envy. In addition, performance for minority classes of negative appearance comparison and envy remain high, F1 scores of 78 and 81. These results suggest it is feasible to detect specific targeted negative affective experiences while consuming content on SNS using the sensor integrated into standard smartphones. A number of limitations impact this conclusion, including the small scale of our studies, their focus on a single image-heavy SNS platform, and in our use of limited number of effective constructs in our surveys. It would be interesting to run a study using Ekman-6 basic emotions instead of the complex model used in our first study. That said, we believe that high performance levels we achieve are sufficient to support design of diverse affect-aware applications and service on SNS. For example, we could create a visualization that presents effective reactions to increase explicit user awareness of their emotional state, or a filter that allows users to configure their feed to display fewer contents that evoke negative affective experiences. We see exploring the design space for affect-aware SNS services as the key next step for this work. Thank you for listening. If you are interested in our work, please feel free to contact us. Happy Kai Days!